Alright, well I already explained in the email the problem, so I'm going to go ahead and just get started. The first thing we do is go ahead and just make an X motion and a Y motion chart, basically just figuring out what we know with the problem. So we know that the initial position in the X value is 0 in this problem, because we see that we're just going to make this 0. And we see that the final value of X is 9.8 meters right here. That's how far along the x-axis that this projectile has traveled. Now, the things we don't know is we do not know the initial velocity. That's what we're looking for in the problem. And we also don't know the time. Now let's look at the y part. We know that the initial y position is 8.4 meters because it's 8.4 meters off of the ground. Now, we see that the final position is going to hit the ground here, so we know that the y position for final is going to be 0. We also know that the initial velocity in the y direction is 0 because the projectile is shot directly horizontal. And we also know that the a is always going to be negative 9.8 meters per second squared, and we also do not know t. So let's go ahead and write the kinematic equation for x. Now we know that the kinematic equation is final x position equals initial x plus the initial velocity times time. Now, we look at this problem and we see that we have two unknowns here. We have the initial velocity that we don't know, that's what we're solving for. We have t. So I can go ahead and just look at the y and see that we have everything we need here to solve for t, to put t there so that way we can solve for the initial vi. So we go ahead and we write the kinematic equation for y. We know that the final position of y equals the initial plus the initial velocity times time minus 1/2 the acceleration times time squared. Now, let's go ahead and plug the numbers in that we know. We know that yf is going to equal 0 because it's going to land on the ground, and that's the final position. And we know the initial position is 8.4. Now we know that the initial velocity is 0, and which is going to make this time irrelevant. It's going to get rid of that time. Minus 1/2 times this 9.8 meters per second times time squared. Now let's go ahead and just move this 8.4 to the other side and get rid of this velocity. We end up with negative 8.4 equals 1/2 minus times, 8.4 equals negative 1/2 times negative 9.8 times the time squared. Alright, now we just simplify by moving this to the other side. We end up with this negative 2 times negative 8.4 over negative 9.8, which gives us t squared. Now, we solve this and we end up with 1.71 equals t squared, and then we square root this and end up with 1.4 seconds as our time. Now, this is our time. So we can go ahead and look at this kinematic equation again and start plugging numbers in. We know that the final position is 9.8 meters, which equals 0 meters, which is the initial, plus the initial velocity times this 1.4 seconds. And just solving this algebraically, we end up with 9.8 over 1.4 seconds is the VI, and end up with 7 meters per second as VI. And we can see just with our we can kind of check our answer just by looking at our values for our units, and we see that meters per second is the velocity, is the measurement for velocity, so we know that we've done this correctly.